Okay, hi everybody. My name is Fred, and I'm working as a release engineer at the Eclipse Foundation. And I'm also the maintainer of the Android client for the Crazyflie quadcopter. And so when I'm not fixing builds for projects and helping them keeping the bar green, in my spare time, I like to build and fly quadcopters. And the perfect combination of both work and fun is this talk, which will introduce the Crazyflie quadcopter and be about developing software for quadcopters with Eclipse. Another cool thing that you can do with Eclipse. So ever since I've been a little kid, I've really liked helicopters. And since helicopters are, well, expensive and it's not easy to learn to fly them, even if it's like a little RC model, I always wanted to have a little quadcopter. So when they became popular, I thought, well, I have to get one, but maybe start small first. So in 2013, I stumbled upon a little article in a German online newspaper or news magazine, and it had an article about this project from a Swedish startup company called Bitcraze, actually 2 Swedish guys and 1 French guy, and they promised this little tiny quadcopter called Crazyflie Nano, which is basically a flying printed circuit board. And so it's small enough to fly around in your living room, and it doesn't really hurt someone if it crashes. So should be a good thing to start with. And you might have noticed that Crazyflie is spelled a little bit unusual. So rumor has it this was kind of a mix-up or a little bit of a typo. The good thing is it really helps if you search for it on Google, and SEO, the search engine optimization, is really good with that term. So yeah, ended up good. So yeah, fast forward to Christmas of 2014, Bitcraze introduced its 2nd generation of a little quadcopter called Crazyflie 2.0, and it's almost the same size, roughly 92 millimeters from motor to motor. Weighs about 27 grams, and it fits in the palm of your hand still, so this is kind of the size. And flight time is around 7 minutes, depending on how much stuff you put on it. And it's a bit more powerful, the motors are a bit bigger, and also the microcontroller is now a Cortex M4, and it has a better radio based on the NRF51 chip, which allows to use both custom 2.4 gigahertz link, but also Bluetooth LE, especially for mobile clients. And another cool thing is you don't have to solder anymore. It just has little connectors, so if you crash, if you break a motor, you can just hook it up with a little connector and it will be flying in a couple of minutes again. One of the best features about it is that it is extensible. So you might know Arduino, they have these shields, or Raspberry Pi, they have the so-called hats, and Crazyflie has decks. And how this works is there are two rows of pin headers, and those pin headers are they go all the way through, so you can put those decks either on the bottom or on the top of it, the little quadcopter. Some of the most popular ones I'm showing here, for example, the LED deck, which consists of a couple of LEDs that can be lit up in different patterns. There's a wireless charging pad. It uses the Qi standard. And there's also kind of an adapter which allows you, that's the big quad deck on the top right corner, which allows you to connect it to brushless motors. So basically what you can do is you have a big quadcopter with bigger motors, and you can put a little quadcopter on top of it and be kind of its brain. And you can still use the same software, same clients, and so on, and just on a bigger scale. There's also a deck for an SD card. If you do extensive logging, for example, you can use that or store some other data. There is a relatively new deck that's in the middle and the bottom. It's called the Z-Ranger deck, which consists of a little time-of-flight distance sensor, which allows to measure very precisely the height to a certain level. And there's already a pressure sensor on the Crazyflie with the usual accelerometers, gyros, and so on. But this distance sensor is more accurate. And one of the latest decks is the so-called flow deck, which consists of the Z-Ranger, the distance sensor, and also an optical flow sensor, which which gives the X and Y position over ground. And this allows to have the Crazyflie fly almost by itself. It depends a bit on the ground, and I will show it later, so you will see it in action. So you probably saw that this is not some kind of little quadcopter that someone buys on Amazon for 20 bucks and gives it to its children for Christmas. The target audience is more geared towards the advanced maker or students, research facilities, some companies that want to build their products on top. And this is kind of the tagline that BitCraze has for Crazyflie: make your ideas fly. So it provides you a platform for that. And sometimes your ideas might not fly, they might crash. But it's very interesting if you're doing some debugging, and if you do something wrong, you could end up crashing that Crazyflie into the wall. So you have an incentive to do good code. But yeah, and the research is done in several well-known institutions and companies. Just for some name dropping, this is done at USC, the University of Southern California, Carnegie Mellon, ETH Zurich, and also MIT. They do various stuff like swarm research, trajectory control, and such things. It's also used in companies, for example, Microsoft, Ericsson, even Bosch. Bosch, for example, they test some of their IMUs, also gyros and accelerometers, on the Crazyflie as a testbed. It's used at DLR, the German space agency, and also at NASA. It's also used by some artists for stage shows, and yeah, especially with the LED deck. And the popularity of it is mainly because it's open source. The whole product is open source. The development was done with open source tools, just like GCC, OpenOCD, FreeRTOS. That's what the firmware is based on. KiCad for the PDB design, and also Eclipse, since this is why I'm here. And so you not only get all the clients, or the clients are not only open source in the libraries and the firmware, but also almost all of the hardware. So you can get the schematics online, and could kind of do it yourself if you want to. So since it's open source, obviously it attracts a community, and the BitCraze itself, they provide their standard client with Python for Linux, Mac, and Windows. And there are also mobile clients available, iOS, Android, and Windows Phone, even though I'm not sure if Windows Phone is still supported, but well. And the community provided some other libraries in different languages like Node.js, Ruby, Scala, C++, C#, and also Java. To make the whole development process, if you want to develop your stuff on top of what's already given, to make it easier, BitCraze also provides a virtual machine image, which includes Eclipse, and yeah, PyCharm and so on, all the tools that I use to do development for the Crazyflie on the firmware side and also on the client side. And yeah, obviously, as mentioned, it's done with open source tools, and especially the firmware, it's done with Eclipse CDT. I'm not a firmware guy, so my knowledge about this is a bit limited, but it requires some at least a GNU GCC ARM embedded toolchain, and there's optional it's optional to use also the plugin for it in Eclipse. And yeah, obviously CDT is the right thing to use for that case. Even though I heard from the guys that use it for firmware development, they say CDT still has some ways to go in terms of how easy it is to configure, because there are a lot of options, and yeah, sometimes it's a bit too much. But still, it's a good tool and helps to develop the firmware. I'll just give a little example later on as well. So the Java library is something that I've done because as I mentioned, I'm the Android maintainer, Android client maintainer, and yeah, I wanted to have a Java library to use for that. And so what I did is I adapted the Python library that is already available, and basically just rewrote it in Java. It's still rough on the edges and does not support all use cases, but the basic stuff works. And yeah, the next goal was to use it in Eclipse, to do some Eclipse plugins that support the development of the firmware. And the first plugin is the bootloader. It's basically a wizard that allows you to either flash the original firmware that's on GitHub, or flash your custom firmware from your development environment onto the Crazyflie. And by flashing, you could do it over USB, but even cooler, it's out of the box. It's provided, or it's supported that you can flash it over the air, so you don't have to be connected. The second plugin, it's almost done. It's not published yet, but yeah, it will be soon, is the config.mk editor. It's a multi-page editor which allows to configure this, or to, let's say, have a nice UI for configuring the options that you want to have in your make process. And yeah, also provide some tooltips and just make it easier. There are other things, or other plugins coming for Eclipse. For example, for the flow deck, there will be a so-called sequence editor, which allows you to easily put together a sequence of tasks, what to do. And so it can fly a special trajectory, like go right, go forward, go left, and do a circle, something like that. And also, I've played around with a prototype for an Eclipse RCP that is basically a client that you can use for just flying the Crazyflie and for controlling it. The only thing is there are some problems with the support in Java for hooking up gamepads, and so yeah, this is still on the list to do. So obviously you want to see a demo, and I'll start with just a flashing process. Hopefully this will work. I'll have to check how I see that on the other screen. But so what I'm using here, just for explanation, this is the Crazy Radio. So this is the other part of the link for the custom 2.4 gigahertz connection. This provides a better range than Bluetooth LE, and most of the laptops don't have Bluetooth LE, so this is the better and, say, more powerful solution. So Let's see if I can do this to exit from here. And so, okay. So what are you basically, what you're seeing here is one of the files from the firmware. And what I'm going to do to just make it easy and hopefully work, as demos are sometimes not working, I'm going to change the startup sound. So you'll hear the original startup sound now, and I will change it, and after flashing, you'll see a different sound. So the original sound is this one. I don't know if you heard it, but yeah, just for beeps that are produced by the motor spinning, and I will change this frequency. So this is going to be tricky because I don't see it. Let me check if I can just quickly change it. Yep, that's what I expected. Come on. Yeah. Okay. Let's see if it works. Nope, that's not what I expected. Okay, well, let's get back to this. I will just have to do some juggling back and forth. Okay, anyways. So I'm just going to take this over to change this one line. And here and enable the other one. And try to do it over here. And I will run the build. So the firmware file is generated. Now I use the wizard. What I have to do first, I have to put the Crazyflie in bootloader mode, which is just by pressing it long. So now it's blinking two blue lights, and it's in bootloader mode. And now I can select in this wizard my own file. So up here, I could have selected the official firmware, and in here, just have to get that over to select it. I'll choose the right one. Okay. So, and flash. So you see green light blinking, takes about 20 seconds. Suspense, suspense, and okay, you did not hear that sound. I'll do that again. I know it's very not very loud. So, but it's a different sound. Anyways, so yeah, that's how the bootloader works and allows you to flash your custom firmware. And what I'm now going to show is a little demo how this thing is flying with the flow deck. And so we just need to prepare the camera to point the other way. So it will take a second. And this demo is run with the Java library. And what I did was to create two patterns. And yeah, let's see if that works. As I said, the flow deck is not perfect. It depends a bit on the underground, or on the ground. If it's too reflective or too uniform, then it might have trouble. But I tested it before, so it should work. Let's see that. And so first one, hands off. and it should fly a figure 8. It's also sometimes thrown off a little bit by its own shadow, but yeah, so that's the figure 8. And for something a bit more sophisticated, I just have to check because some of the motors are a bit loose, so that's why I have to double check. Oops. And the second is doing some other movements, basically going forward, doing turns, going backwards. And almost starting or landing at the same spot. So yeah, that's the flow deck and its things. And yeah, so obviously it can fly on its own, but it's still fun to fly it by itself. And so what I'm going to show now is using it with the Android client, which I have on my phone. And I'm just connecting the Crazy radio over the USB dongle. And I also have connected a PlayStation 3 gamepad. And if it works as expected, then I should be able to fly it. So it's it's pretty stable, and for beginners, there's things like altitude hold with the distance or the set ranger deck that measures the distance to the ground, and there's also support for the downlink from the quadcopter, so you can have data like the orientation or the height, something like that. You can have that on your Android phone. And if, for example, I would use the LED deck, then you can also, on the buttons of the gamepad, there's options to change the patterns and so on. So yeah, as you see, it's a great thing to work with and to do some development, but it's also very nice to fly. Okay, so let's get back. Oops. Oh, here we go. And yeah, so that's basically it. The talk is a bit short, I know. If you would like, I can show you a little video that shows some of the research projects. And before doing that, just to give you some links, go check out the website of Bitcraze, bitcraze.io. They post every Monday, they post a blog post, and you see all the new things that are coming out, new decks and so on. You can see all the source code on GitHub. You can follow them on Twitter. And if you want to see some of the, or even more videos about research projects, you can check out their YouTube channel. So yeah, let's see if we can watch a video. Come on. So, it has no sound, so that should work fine. And oops. So that's some research done at the USC, trajectory control, and those Crazyflies, the swarm of Crazyflies flies through some obstacles, and the task was to yeah, fly around each other without being affected by the downforce of the wind. And it actually shows also the logo USC, which is pretty nice. And Crazyflie can also paint. For that, it has a little brush in the front, and it's just used to put the dots on the paper. So you see it in slow motion. And yeah, something like that could result. If you know this guy, then extra bonus points. BitCraze, or the Crazyflie, was also used in a TED Talk. And also, yeah, used for swarms. So yeah, I guess the sound is missing, but still impressive. Just how Crazyflie is used in different applications. Okay, so that's it. Anyone have any questions? Sure. So the question was, what kind of programming language is used for such demos with swarms and in the research projects? So it depends a bit. There is, with those projects at the universities, they mostly use motion capture tools, big, very expensive cameras that track the Crazyflies, and they use what's the name of the tool? It's I think ROS. Yeah, ROS is the name, and yeah, such tools to do that, to code the movement and the trajectories. There's also some, obviously there's some custom code that they use to in the firmware and also on the controlling side, different algorithms, even MATLAB and so on. That's what they use. Any other questions? Yeah. So the question was, how do they do navigation indoors? And as I said in the things that I've shown now, at least in the first one, that's done with the VCon system, which uses cameras. But at least with the last talk or the TED Talk, they used ultra wideband link and used that to do kind of indoor GPS. And the cool thing is, this has so far only been used in research and was also quite expensive. But BitCraze, the company that does Crazyflie, does not only do Crazyflie itself, but also other tools. They're electrical engineers, and so what they did is they also used this ultra wideband chip and provide, or actually you can buy it. It's a toolkit for doing that same thing, doing indoor navigation, and for, I think the price for they have like different anchors that you can put in a room, and the price is about €1,000 compared to 100,000 euros for such a motion capturing system. It's very affordable. Maybe not for everyone at home, but for researchers and so on. So that's what they can use. And now, well, as I've shown with the optical flow deck to a limited amount of accuracy, it's also possible to do it on the quadcopter itself. Any other questions? Nope. Okay, then yeah, thanks very much.